Scientific notation. Scientific notation is a way to express very small or very large numbers that is often used in scientific calculations, where the analysis must be very precise. Scientific notation is a way of writing a number as a multiplication problem where the first number is greater than 1 but less than 10, and the second number is a power of 10. So here are the exponential form and their standard names. So we have 10 to the power of 6, which is equals 1 million, 10 to the power of 5, which is equals 100,000, 10 to the power of 4 equals 10,000, 10 to the power of 3 equals 1,000, 10 to the power of 2 we have 100, 10 to the power of 1 we have 10, 10 to the power of 0 equals 1, 10 to the power of negative 1 we have 0.1, and 10 to the power of negative 2 we have 0.1 hundredths. Then 10 to the power of negative 3 we have 0.1 thousandths. To change from standard form to scientific notation, first, place decimal points such that there is one non-zero digit to the left of the decimal point. Count down of decimal places. The decimal has moved from the original number. This will be the exponent of the 10. Number 3, if the original number was less than 1, the exponent is negative. If the original number was greater than 1, the exponent is positive. Here are the examples. We have 4,750,000. So, the scientific notation is 4.75 times 10 to the power of 6, in which we have 4,750,000. So the decimal of this number is here. Then we move this one to the left. So here, the non-zero digit number. So we have 4.75 times 10 to the power of, we have 1, 2, 3, 4, 5, 6 moves. So to the power of 6. So our scientific notation for 4,750,000 is 4.75 times 10 to the power of 6. The second example is 0.00789 equals 7.89 times 10 to the power of negative 4. So we move 4 decimal places to the right. So let's try this another examples. So we have 61,500. So what is the scientific notation? So for that we have 61,500. So here is our decimal. So move this one to the left. Let's count 1, 2, 3, 4. So we have 6.15 times 10 to the power of negative 4. I mean positive 4. So this is our scientific notation. The exponent is positive. It's because our original number is greater than 1. For the second example, we have 84,960,000. So we have 84,960,000. So here is our decimal. So as what we have done in the previous examples, we just move our points to the left since the original number is greater. So let's count 1, 2, 3, 4, 5, 6, 7. So we have 8.496 times 10 to the power of positive 7. And for number 3, we have 321. So as what we have done in the 1 and 2 example, so we just move to the left the decimal point since it is greater than 1. So we have the answer to this is 3.21 times 10 to the power of 2. And for number 4, 0.00527. So the answer for this, so we move the decimal to the right. So we move the decimal 4 decimal places. So we have 5.27 times 10 to the power of, since the original number is less than 1, so our exponent is negative. So we have negative 4. And for the last one, we have 0.00004. The scientific notation of this is 4.4 times 10 to the power of, let's count. So we have 1, 2, 3, 4, 5, 6, 7. So we have negative 7. It's negative, it's because the original number is less than 1. So remember, the first number must be 1 or more, but less than 10. That means the first number before the decimal point can be 1, 2, 3, 4, 5, 6, 7, 8, 9. To change from scientific notation to standard form, first, move the decimal point to the right from positive exponent of 10. Move the decimal point to the left for negative exponent of 10. Examples, we have number 1, 5.024 times 10 to the power of 3. So, since our exponent is positive, so we move the decimal to the right. So we have 5,024. For number 2, we have 1.15,000 times 10 to the power of negative 8. So the result is we move the decimal point to the left into 8 places since our exponent is negative. So let's try this one. So write in standard form. So for number 1, we have 1.09 times 10 to the power of 5. So since the exponent is positive, so we move the decimal to the right. So as what the step said. So we have first move the decimal point to the right from positive exponent of 10. So this is. So we move this decimal to the right. So we have 1, 2, 3, 4, 5. So we have 1, so from here our decimal, so we have 1, 2, 3, 4, 5. So the answer of 1.09 times 10 to the power of 5 is 109,000. Example number 2. We have for number 2 is 4.2273 times 10 to the power of 4. So as what we have done in the first example, we just move the decimal to the right. So from here, we move decimal to here. 1, just count. 2, 3, and 4. So here is our decimal. So our answer is 42,273. This is our standard form. Example number 3, we have 9.42 times 10 to the power of negative 3. So since our exponent is negative, so we move the decimal point to the left. So we have here, from here we move this one to the left. So we have 0.00942. So this is our standard form of 9.42.